Welcome to Homemade Mathematics. My name is Sierra and today we are going to be talking about the power rule. We are going to be looking at some basic examples and how this works, as well as combining this with our product and quotient rule and negative exponents for some more challenging problems towards the end. So if that sounds interesting to you, stick around. So I want to first look at how and why this works. If you've watched any of my exponent videos before this one, that is how I always start. I start with how and why it works. So if you see this here, you see we have a variable to an exponent to another exponent. That is what we call the power rule, when we have an exponent to another exponent. And how this works, if you think about it, we have a squared to the third. Right? If we had a to the third, that'd be a times a times a. So if we have a squared to the third, that's going to be, which then you could use our product rule, which tells us if you have something with the same base being multiplied together, you add up your exponents to get a to the sixth. Or you could expand it even further, which we know each of these a squareds are a times a. Either way, we get a to the sixth. So when we were doing product rule, we were having two things or multiple things being multiplied together where we were adding their bases. This time, we have an exponent to an exponent. Notice the difference. Notice how this looks different from this. And we are not adding the exponents anymore. If you look at these exponents and look at what my answer was, we're no longer adding, we're multiplying. So we now have this nice little rule for power rule when we have an exponent to an exponent. If we have a base with an exponent to an exponent, we are going to keep that base and just multiply our exponents. So let's take a look at a couple basic examples. For this first one, it's going to be pretty straightforward. We have a to the fifth in parentheses raised to the third. So that's where we're going to use our power rule, and we're just going to multiply those together, right? We could do a to the fifth times a to the fifth times a to the fifth. 5 plus 5 plus 5 is 15, but we have our new rule now, which we can just multiply to get that a to the 15. With our next one here, it's again pretty basic with two power rule examples, but then you might notice we're going to have to use that product rule at the end. So let's do our power rule first, which is going to have us multiply those exponents together. So we get a 2 times 3 to the sixth, and then we're taking that times 4 times 6, so a to the 24th. But now notice how this is different to this, right? I don't have 6 to the 24th. I'm not multiplying them. We're using our product rule, which tells us to add them. So 6 plus 24 would get us our a to the 30th. All right, number 3 you might notice is a little different because we have that exponent out there and we have two things inside the parentheses. And we should know from distributing in the past that that 7 has to go on to both things in the parentheses. All right, if there was a 2 in there, it would have to go on to the number as well. It would be 2 to the 7th, and so on. You have to distribute that to everything in the parentheses. If we do that here, we have a, 2 times 7, so a to the 14th, 3 times 7, b to the 21, over, and then we just have our a to the 8 over b. And now we can use quotient rule to simplify, right? Up here we use product rule to simplify. Now we can use quotient rule, which tells us to subtract. So 14 minus 8, we get a to the 6th. 21 minus, if there's not anything there, it's 1. So 21 minus 1, we have b to the 20th. Let's take a look at some harder ones. As you can see, I have some more challenging problems up here now, so if you want to pause the video and give these a try, I have our little hints up here for all of our rule, product, quotient, negative exponents, and our power rule. So if you want to give those a try, go ahead. Otherwise, keep watching. Number 4 up here, you can notice we have to distribute like we did in that last one. And this is where we have to distribute to a number like I was talking about. So we have 2 to the third. A to the 2 times 3 is 6. And b to the 4 times 3 is 12. Right? Because remember, exponent to an exponent, we're multiplying. If I have a number to an exponent, I want to go ahead and simplify that out. So 2 to the third, 2 times 2 is 4, times 2 is 8. So we have 8, a to the 6th, b to the 12th. These last two would usually probably scare a lot of people. But if you take it one step at a time, it's really not that bad. Keep in mind there's also different ways you could go about this. You could go in a different order than I'm going in. This is just the order that makes the most sense to me. So I'm going to go ahead and start by distributing just like I did up with this other one. So we're going to have 5 squared, which we can go ahead and say 5 times 5 is 25. We have a to the negative 3 times 2, so a to the negative 6. We have b to the 4 times 2. And we have c to the 5 times 2. 10. Now, keep in mind, we still have this on bottom. This 2 was not distributed onto that, right? The whole thing, if this whole thing was in parentheses, yes, this 2 would have to come down here as well. Okay, that is an important note to make. So if the parentheses were over this whole fraction, this 2 would need to be distributed down here as well. However, it's only on the top part, so that's just going to stay b to the 12th, c to the negative 2. Now that I've distributed, I'm going to go ahead and move my negative exponents so that they are no longer negative. Some people don't do this step. Some people just subtract with negatives. I just think this makes the most sense to me, so that's why I do it. You might notice we have 2 things with negative exponents. So this a to the negative 6, that guy's going to come down here. So that a to the 6th is now on bottom. Got rid of that negative exponent because we do not like negative exponents in our answer. If you have not, go ahead and watch that video. I'll put a link for that here. And also this c to the negative 2, but it's on bottom, so to get rid of that, we're going to bring him up top. And then I leave my last step as the combining. All right, so I'm going to see different things I can combine here. So 25, there's no other coefficients, so I know that 25 is going to stay on top. I have my a to the 6th on bottom. There's no other a's in here, and remember, none of these rules work unless they have the same base. So that a to the 6th, we had to move it to the bottom, it's going to stay down there. If I look at my b's, you notice I have 8 on top, 12 on the bottom. Quotient rule tells us to subtract. 12 minus 8 is 4, but I had 8 b's on top, 12 b's on bottom, so those 4 that I have left over are going to be on the bottom. And then lastly, my c's, I forgot to cross those guys out. They moved up here, which they're next to each other, which tells us we're multiplying. Product rule, which product rule tells us to add our exponents. 10 plus 2 is 12, and they are on top, so we have our c to the 12th on top. Now, you can see we don't have anything else that can be combined. I have no negative exponents, so that would be my simplified answer. And our last example here, again, there's different ways you could have gone about this. If you want, you could start by moving this whole thing to the bottom and having it to the positive 2, or you could distribute out that negative 2, whichever way you want to go about it. I'm going to go ahead and just distribute it out. So we'd have 3 to the negative 2. A, if there's nothing there, it's a 1, so 1 times negative 2, negative 2. And then b, negative 2 times negative 2 is a positive 4. Again, notice it's only going on to this part, not the bottom, because it's not in the parentheses, so that a to the 4th, b is going to stay on bottom. Once I've distributed, I'm going to get rid of my negative exponents. So this guy's got to move to the bottom so that he becomes 3 squared. And this guy's got to go to the bottom so that he becomes a squared. That b to the fourth is going to stay there because he's positive. All right, last step, I can combine. Let's see, we have b's. We have 4 b's on top and we have 1 on bottom. So if we subtract, we'd have 3 left on top. Notice my a's are together on bottom, so we're going to use our product rule because they're together, so we're multiplying. And when we multiply, we add the exponents. So a, 4 plus 2 to the 6th. And then remember this 3 squareds down there as well, which 3 squared is just 9. Okay, now you can notice nothing else we can combine, no negative exponents, everything is in simplest form. So with some of these bigger simplifying problems with exponents, the strategy I like to follow is distributing first. If there's parentheses, do your distribution first. Then get rid of your negative exponents. If it's on top, move it to bottom. If it's on bottom, move it to top. Then you should be able to just combine to simplify. If you had an A on top and an A on bottom, subtract, use your quotient rule. If you have an A on top and another A on top, you're going to add your exponents, product rule. Okay, so it's bringing all of these rules together. I hope this video and this series was helpful for you. If it was, please give it a thumbs up. If you have a request for any questions or any specific problems you want me to do, I would love to create a separate video just on challenge problems involving simplifying exponents. So if that's something you'd like to see, go ahead and comment below and maybe you will see your question featured in my next video. We'll see you next time.